We've been looking at representing integers in base 2 or binary form, which is what computers use for numbers, and doing addition, subtraction, and multiplication in binary, which is what computers do with those numbers. We now come to the fourth of the basic arithmetic operations, division. In this video, we're going to see how to do division of two integers in binary. Division is much more complex than the other three arithmetic operations. Just as with earlier operations, it's helpful to look at an example from the base 10 world and to think about the algorithm we use. This algorithm is something in school we learned as long division. As with all algorithms, let's think about the inputs we need, what the instructions are, and how to know when to stop, and also what the outputs are. So let's look at the example where we divide 90125 by 12. The inputs are the two integers, and the order here matters. The way the long division algorithm proceeds is we first try to divide the divisor, that's the 12, into the leftmost digit of the dividend, that's the 90125. We write down how many times this goes. In this case, how many times 12 goes into 9? Well, 9 is smaller than 12, so 12 doesn't go into it at all. We write 0 in the quotient, which will eventually be part of the answer, to indicate this. To move to the next step, we multiply 0 to 12 and write this below. Then we subtract. 9 minus 0 is 9. Then we bring down the next digit, which gives us 90. Now repeat the instructions. How many times does 12 go into 90? Well, in this case, it does go, in fact, 7 times. So we put a 7 here and multiply 7 times 12. That gives 84, which goes here, and then we subtract to get 6. Bring the next digit down, and then repeat. 12 goes into 61 5 times. Multiply to get 60, write that down, and subtract. Bring down the next digit to get 12. 12 goes into this once, so put a 1 here, multiply, subtract, then bring down the next digit. 12 does not go into 5, so 0 goes here, multiply, and subtract. There are no more digits to bring down, and 12 cannot go into the previous result, so the algorithm terminates. This shows you another thing that makes division different, namely that it results in not one but two numbers, a quotient and a remainder. In this case, the answer is a quotient of 7,510 and a remainder of 5. So we say 12 goes into 90125 7,510 times with 5 left over. You may have a lot of questions about this process. Why does it work? Does it always work in the sense of producing correct results? Does it always terminate, or could we feed it input that would cause it to go on forever? We'll be addressing these questions in time, but for now, here's what's important about long division for the purpose of connecting it to binary integers. First, it works by taking the smaller of the two integers and checking to see how many times it goes into successive digit chunks of the larger one. Then it involves a multiplication and a subtraction step. Then we notice that the algorithm stops when we run out of digits and the small number can no longer go into anything, and this produces a quotient and a remainder. Let's see how this works in binary by attempting to replicate the long division algorithm for the problem of 11001 divided by 11. In decimal, this is 25 divided by 3, so the answer is supposed to be 8 with a remainder of 1. So set up the problem in the same way we do with decimals and proceed in the same way. Look at the leftmost digit of the dividend. Again, that's the big number in this case. 1 does not divide 1, so put a 0. Multiply and then subtract and then bring down the next digit. 1 goes into 1 once, so put 1 here. Multiply, subtract, and then bring down the next digit. 1 doesn't go into 0, so put 0, multiply, subtract, then bring down the next digit. Again, 1 doesn't go into 0, so put 0, multiply, subtract, then bring down the next digit. 1 doesn't go into 1 either, so put down 0, multiply, and subtract. There are no more digits, and 1 doesn't go into the digit we have here, so we're done. And as hoped, the quotient is 1000, which is 8 in base 10, and the remainder is 1, which is 1 in base 10. Let's try that with a more complicated example. 1001, 1001, 10 divided by 1100. In decimal, this is 614 divided by 12, so the answer should be 51 with a remainder of 2. Let's see if our process works. Setting things up as usual, we check with the digits moving left to right. 1100 is pretty big, so it doesn't go into 1 or 10 or 100 or 1001. So we'll put a 0 above each of the 4 leftmost digits. We could multiply by 0 and subtract at each of these steps, but this wouldn't result in anything, so instead we'll just keep putting zeros until our quotient goes in. Here at this point it does. Now, how many times does 1100 go into 10011? At first, this seems hard, but it's actually very easy because the only digits you have to work with are 0 or 1. So the question isn't how many times does it go in, but rather, does it go in or not? If it does, we put a 1. If not, we put a 0, like in the previous steps, and move on. We don't have to think about how many times the quotient goes in, because if it went in more than once, we would have detected this in an earlier digit. So here, 1100 goes in once. Put a 1, multiply, which is just copying the number down, now subtract. The subtraction is the only really non-easy computation involved, and it helps to see this done separately. I'm subtracting 1100 from 10011. So as we saw a few videos ago, the first 2 digits involve no borrowing, but the 4th digit requires that I borrow a 1 from the 8th place. But the 8th place is a 0, so I have to move on up to the 16th place. There is a 1 there, so borrow it to make this 0 in the 8th place into a 10, but then borrow 1 from that to give to the 4th place. That 4th place is now a 10, and the 8th place is a 1. Now all the subtraction can take place, and we end up with 0111. Notice this is smaller than 1100. 111 is a 7 in decimal, and 1100 is 12. So this is like in decimal division. We know we've not made a mistake because the result here is smaller than the divisor. Now bring down the next digit, again, just like in decimal long division. That gives 1110 here. 1100 does go into this, which we know because 1110 is larger than 1100, and we know that by looking, because 1110 is 1100 with an additional 2 added on there in that second bit. So 1100 goes into this. Therefore, put a 1 here, multiply, and subtract. The subtraction is easier this time because there's no borrowing. We are left with a 10. Bring down the next digit to get 100. This is smaller than 1100, so 1100 doesn't go into it. So we put a 0 up on top. I'll multiply by 0 this time and write down the result so as not to lose track of where I am. Subtracting here just gives 100. Bring down the next digit to get 1001. This is still smaller than 1100, so it goes in 0 times. Multiply and subtract to get 10011. Now it so happens that we did this earlier and we saw that 1100 goes into it. So we put a 1, multiply, and the subtraction is the same, so we know the result is 111. Bring down that next digit and we get 1110. We saw this earlier too, and we know that the 1100 goes in, so put a 1, multiply, and then subtract to get 10. The long division stops here because there are no more digits to bring down, and the result is smaller than the quotient. So looking at the work, we have a quotient of 110011 and a remainder of 10. That quotient is 51 in decimal, and the remainder is 2, which is what we were supposed to get. I think this needs one more example, and it's time for you to try it out. Use long division in binary to divide 1100001001 by 10110. Pause the video and work this out. You can check your work and get some practice on earlier concepts by converting these to decimal and seeing what the quotient and the remainder are. So here's the work on this. Check your own work against this on each step and see how you did. Remember, you are just now learning this process, so there's a strong chance you might have made a mistake here, especially in one of the subtraction steps, and that is okay. The main thing here is to debug any mistakes you made, find them, and fix them, and then you'll be good to go. So in this video, you refreshed your memory about long division and learned how to apply the algorithm for long division to integers represented in binary. You now have all the tools you need to perform all the basic arithmetic that math is based on using only binary integers. That's a major accomplishment, and you should take a moment to feel good about that. In the next video, we're going to leave the binary world for a moment and dig a little more into this long division process by looking at the division algorithm and the very important modulus operator, which is used in many different computer science applications. See you there.